You can't, I could, right?
I don't know.
Take your mass and divide by, look at your units. Your units are grams over moles. So you take the mass, divide it by the moles. Your units tell you what math you need to do. Okay? All right. So, you're going to make 200 cookies. You're going to make 200 cookies. We know that 1 cup of butter makes 50 cookies. There are 2 cups of butter in a pound of butter. I use a lot of food analogies in this class. Okay, so what do we know? We know that 1 cup of butter makes 50 cookies. We know that 2 cups of butter are in 1 pound of butter. So all I did was I took the second statement here and I made it into a ratio. You could write 50 cookies over 1 cup. It doesn't matter how you write it, the relationship will stay the same. And then I know that 2 cups of butter in every pound. Or I could write 1 pound contains 2 cups, right? 1 pound over 2 cups. The relationship stays the same. All right. So I want to find the number of pounds of butter I need. Do I have pounds in any of these ratios? So the answer, units, are in one of these ratios. So I'm going to flip that ratio so that pound of butter is on the top. But now I've got cups of butter. I don't want cups of butter, I just want pounds. Is there another ratio that has cups in it? So when you do dimensional analysis, it's always a ratio times another ratio. So you put an X, I'll move this up so you can see. So you put an X, and then we're going to put the next ratio. The next ratio has to have what was on the bottom of the previous ratio, but on the top. Because if it's on the top and the bottom, it will cancel out. So I'm going to use this ratio. And I'm going to put 1 cup over 50 cookies. Now, my unit cup is going to cancel because it's on the bottom and the top. I don't cancel the numbers. Now I know that 1 pound makes 50 cookies. What can I multiply that by to get rid of cookies? What other number is up there? What other number?
Cookies.
You just said it, cookies. Well, what's the number?
200.
200.
Cookie.
200 cookies. So now cookies cancel. What unit do I have left? I only have pounds in my answer, so I'm finished. So what you do now is you take every number that's on the top half of the ratios and you multiply them. And you divide by every number on the bottom, and that will tell you numerically how many pounds of butter we need. So you're going to take 1 times 200. You're going to divide by every number on the bottom. So we're going to divide by 2, and we're going to divide by 50. And what number do you get?
2.
2. So you've just shown me how to do the math that you could do in your head, right? So when you're asked on an exam or a test an answer to a question, you have no idea what formula you're supposed to use. You can use your units. And sometimes in university, they'll put questions on an exam that you swear you've never seen anything like that before in your life. I know, it happened to me. This can save your life. Literally. Because you won't kill somebody, because you can't do your homework, because you won't go to jail. Okay? All right. You ready for a tougher question?
Sure.
Okay. How many years would it take you? How many years
2.
to spend 1 mole of pennies if you spend 1,000 pennies per second? How many years will it take you to spend a mole of pennies if you spend at a rate of 1,000 pennies per second? So now you have a way to convert your information so that you find your answer in years. So which one of these ratios do you want to start with? You just randomly picking that one?
Because we already have
What are your units that you want in your answer?
years.
Years. So you have to pick the ratio that has years in it. Okay? You have to pick the one with years in it. So which one is that?
The last one.
The last one is years on the top.
Yes. No, I'm talking about the equation.
Are years on the top? No, so you flip it. So 1 year, 365 days. Now the thing about this too is once you use a ratio, you don't reuse it. So we want to get rid of days. Do we have anything up there that's got days in the ratio?
Yes. Second one.
Which one are you going to use?
Second one.
This one?
Yes.
So 1 day, 24 hours. Why did days go on the top and not hours? Rachel. So they cancel out. Days are gone. But now I've introduced hours. But I know 1 hour has 3,600 seconds. So now I've got rid of hours and I'm down to seconds. Do I have any other ratio that's got seconds in it? I know in 1 second I can spend 1,000 pennies. So seconds cancel. But now I've got pennies. Do I have another ratio that's got pennies in it?
Yes.
What's the number?
6. The Adriano number.
Yep. There we go. something in your calculations. But this is the beauty of it. Go back and double check. Okay, 1.9 times 10 to the 13.
Other question, if it was 1.9089.
It's okay, because really, what did you get? 1.
9089. Oh, yeah, now I know. But if you only leave the.
It's times 10 to the 13, right? So really, we're talking, because there's only one significant digit in 1,000, we're talking 2 times 10 to the 13 years. You could not spend a mole of penny in your lifetime. You could not spend a mole of pennies in your lifetime, spending 1,000 pennies a second.
It's unfortunate.
It is unfortunate, because you'd be very rich. Okay? So that's basically how we do dimensional analysis. So let's write these out anyway, except you would have put a letter with them. So we know molar mass, we know Avogadro's number, and we're given a mass. Now, this question gives you mass in milligrams, but molar mass is in grams. So you also need the conversion factor of milligrams to grams. Okay, how many molecules are present in 2.6 milligrams of water? So we're looking for molecules. Which one of these ratios contains molecules? The 6.02, the Avogadro's number. So we're going to start with that one. So we want to get rid of moles, so our next ratio has to have moles in it. Which ratio has moles in it?
First one.
The first one, but we have to flip it so that our moles can cancel, our mole units. Now we've got grams. We want to get rid of grams. What ratio has grams in it?
First one.
So 1 gram, 1,000 milligrams. Gram units cancel. But now we've got milligrams. We need to get rid of milligrams. So we multiply it by 2.6 milligrams. So that's on the top, that's on the bottom. So in your calculator, 6.02 times 10 to the 23 times 2.6 divided by 18.02 divided by 1,000.
What about
Digits.
8.68 times 10 power of 19? Yeah, more than two.
Anybody else get this number?
Yes.
All right, how many significant digits can we have?
1.
Nope, 2. Okay, so you're never going to use the significant digits from a conversion factor. So this is never going to be part of your deciding factor. Always go. Usually it's whatever piece of information they give you in just the question. There, you did a question with no formulas. Okay, now let's do it with formulas. Same question. We've got 2.6 milligrams of water. So you have to convert that to grams. We know the molar mass, that's mass. We know the molar mass. 18.02 grams per mole. We know Avogadro's number. See, it's the same information. And we want to find big N. So using formulas, you've got two formulas. You've got this one, and you have this one. You will be able to find the moles using one of those two, and then you're going to take that value and place it in the other equation to find the unknown that you're looking for. So in this case, we have mass and molar mass. So how many moles is that? So what did you say, sorry?
1.4 times 10 to the power negative 4.
Except you just lost half a mark.
Mole.
Okay, you just lost another half a mark.
Good job, buddy. Keep going.
How many significant digits on top?
Oh.
2. These are leading zeros. How many are on the bottom? 4. So your final answer is going to get rounded to 2. So don't have 2 now. Carry at least 3. All right, now we know the number of moles. I'm sure that's what you meant to tell me. Now you know the number of moles. You're going to plug it in the equation.
Do you have to show the units when you're multiplying?
Yep. So you make, or rather you have, 8.7 times 10 to the 19 molecules. So that is the same answer as you got using dimensional analysis. You do not have to write out the questions both ways when you do them. I want you to practice doing dimensional analysis now, because it gets you into the groove of how to use it. But the beauty of this comes when we've got like 5 steps to solving a question. And you can do all 5 steps on one line. Okay? Are you okay with that? What I want you to do is I want you to finish the rest of the questions on the sheet. You can use dimensional analysis